cos of cos inverse and cos inverse of cos. Okay. Now, if you remember, let's just think back to 2 hours ago. The first one we did was this. Okay, do you remember? Now, which one was which? I think back to this inside part, okay, which is the definitive part, right? So since sine inverse has that restriction on it, the whole thing also has its restriction. So that's why you only get one small section of y, sorry, that should end, of y equals x, okay? So when you flip it around, I don't know if any of you came up with a wording for this, right? In the middle, it's still the same. But as you go for outside that middle domain from minus pi 2 to pi 2, what do you get? You get this kind of shape. Right? Now, how would you word it? Here's what I would word. So if you haven't written down, an explanation for what happens outside this domain of minus pi 2 to pi 2, here's the way I would say it. I think what you get is horizontally shifted versions. Horizontally shifted versions of, now, what graph does it look like? Well, see how it's going up and down and up and down? Yeah, it's kind of like the absolute value of x. I think that's the closest comparison. Now, I know a lot of you, when you look at it, it kind of looks like sine x, but pointy, okay? As you'll see when we look at mainly cos, right, that comparison starts to break down. It's actually closer to this kind of line, right? Because that's what the equation of this part is. That's y equals x, that middle branch section, whatever you want to call it. Okay? All right, now, what happens when you take the other ones? Cos of cos inverse and tan of tan inverse and so on. So let's do this one first. Okay, now, let's try, rather than just, bluntly putting in values, okay? Let's try to apply some of the logic from what we saw over here and think about this, okay? So, for what values of x do you think it's going to exist? Where's it going to work?
Minus 1 to 1.
Yeah, just like this sine inverse of x, right? Since there was a restriction on that, you're going to get the same kind of thing happening here, right? And since this is minus 1 to 1 and this is minus 1 to 1, you're going to get exactly the same restriction, okay? So to cut a long story short, I missed. Yep, okay? You're getting the same graph, okay? So cos inverse and sine inverse, they're actually equal to each other within that domain, okay? Now things get a little more interesting. I'm going to rub this off in a sec because it's pretty boring. When you think about cos inverse of cos x, okay? So let me get rid of, here we go, this one. Okay, now, come back over here, right? Remember that this was equal to x in this domain here, from minus pi 2 to pi 2. Okay, now that restriction is not an accident and it's not arbitrary. That restriction comes from this restriction, right? That this is limited between minus pi 2 and pi 2. Okay, now think for a second. When we did cos inverse, when we decided where we would restrict cos inverse, we came up with a different restriction, didn't we? What was its restriction?
0 and pi.
Yeah, 0 to pi, right? Okay, so therefore you ought to expect the same kind of pattern to happen here, right? So you're going to get y equals x within this domain. Okay, so I'm going from here to here. That's y equals x, okay, and that's 0 to pi. Okay, now what would you expect to happen after that? Now keep in mind, remember, sine and cos, right? Sine and cos, they're the same graph, but they're shifted horizontally, okay? Now I've also got this vertical shift happening because I've chosen a different restriction, okay? But you're basically going to get the same shape. It's going to bounce, just like sine inverse of sine bounced, okay? Now here's why I was trying to make this comparison before to the absolute value of x rather than saying it's like sine but straight, okay? This graph here, y equals cos inverse of cos x, it looks nothing like cos, right? What does cos look like? It looks like this. it doesn't really line up, does it? Okay, like you could kind of say, oh, it's upside down and it's shifted,
down.
But the yeah, because you know it's high here and low there, but the comparison really breaks down, right? So instead, I'm going to connect it to the absolute value of x again, right? So this part here is another horizontally shifted version of the absolute value of x, right? So it's been moved over that far. Okay. Now that'd be 2 pi. This would come down to 3 pi. If I drew that far, you get the idea.